So now we want to put all the transformations together because we may have multiple transformations in one new function. So how do we do it? Well, sometimes the order might not matter, but in general, the order does matter in which you do the transformations. So the official prescribed order is as listed here. We want to do any horizontal shift first, any stretching and compression second, any reflections third, and last should be any vertical shifts. All right, so we'll see these in the examples of how we can determine what's what. This is how we should do the transformations. So let's look at an example. Okay, so what we're going to do, and that order of transformations for the most part means you're basically going to be working from the x outward. There are some places where that is not so clear, but for the most part, that's what we're going to be doing. All right, so we're going to start with a horizontal shift. So this first, so what I'm going to do is basically lay out a plan for this. Call it a game plan. So what we're going to do is we're going to start with absolute value of x, because that's what basically this function is at its core. Then the next thing is I'm going to do any horizontal shift, and that would be the absolute value of x plus 2. Now we're not really multiplying by any numbers, so there isn't any stretching or compressing, but then does come a reflection, so I get negative absolute value of x plus 2, and then finally we have that final plus 2 on the outside, and that's a vertical shift. So negative absolute value of x plus 2 plus another 2. All right, so that's the order I'm going to do these in. So here we go. We start with the absolute value of x. All right, so I'm going to start by putting an axis here. All right, then I'm going to do the absolute value of x. So I'm only going to do one graph per axis, set of axes. So I'm going to do them all filled in, not with dashed lines or anything. Okay, so that's the absolute value of x. And I know that there's an important point there at the origin, so I know 0, 0 is on the graph. I like to have at least 2 points, but I'm going to pick up a point as we go along and see what makes sense to track as well. All right, so the next would be to do this absolute value of x plus 2, with the plus 2 being inside. So that, if I'm looking at absolute value of x plus 2, so what's that has done is taken the previous one and added a 2 to the x, so it shifts it back 2. So 1, 2. So there's the new end of the corner of the absolute value of x graph, and I just get this. Okay, so this point is now negative 2, 0, because I moved that 0, 0 point back 2 in x. And then now let's think about what this point is in my new graph. Well, that's putting x of 0 in, but if I put an x of 0 in, I get absolute value of 2, I get 2. So this must be the point at 2 here, or in other words, the point 0, 2. All right, that will be helpful moving forward. All right, so then the next thing is I go to a new graph here, and now I'm going to do the negative absolute value of x plus 2. So that negative on the outside is just a flip. It's a vertical flip. So a flip over the x-axis. So that point that was at negative 2, 0 stays there. but everything else gets flipped. So that point that was at positive 2 on y ends up at negative 2 now. And so I get the whole thing flipped over like this. All right. And finally, I'm now going to add 2 to the end of this function. So now I'm doing negative absolute value of x plus 2 means I'm going to take the previous one that we just had and notch it up by 2. So that point at negative 2, 0 goes up to negative 2, 2. And that point that was at 0, negative 2 goes up and ends up at the origin at 0, 0. All right, and there's my final sketch of negative absolute value of x plus 2 plus 2. Okay, let's take a look at the next one. All right, so again, let's set up a plan for this. So in here I see, again, I see that the most basic function in there is an x squared. So I'm starting with x squared. All right, and then I want to look for any horizontal shift, but that's the x minus 3 squared. And then I look for any stretching and compressing, so some multiplication. Well, that's where I have the 1/4 x minus 3 squared. And then I don't have any reflections, so because there's no negative multiplied anywhere. So then I'm going to do the final minus 1 vertical shift. All right, so let's put it all together now. I'm going to start with my basic x squared graph, which also sits at 0, 0. And then I'm going to do the x minus 3 squared. So again, if I'm doing x minus 3 all squared, I subtracted 3 from the x, so this is going to be some sort of horizontal shift, and because I subtracted 3, that's going to move it to the right 3. 1, 2, 3. And now I'm going to get, whoops, I don't like the look of that. Oops, I lost my axis. Let me fix that. All right, so there is now my x minus 3 squared, which is sitting down here at 3, 0. Now I'd also like to get this point over here. But again, that's putting an x of 0 in. So if I put x of 0 in, I get 0 minus 3 squared, so minus 3 squared, which is a 9. So that's actually at the 9 value there, hence this is the point 0, 9. That will be helpful. And it doesn't matter that the units on the y and x are not the same markings. We're not concerned with exactness here. We're trying to get an idea of what the picture looks like. Okay, now the next thing is I'm going to do this multiplied by a 4th. So I'm going to do a 1/4 x minus 3 squared. So that's taking what we had previously and multiply it by a 4th. All right, so that's sort of some sort of vertical stretching or compressing. Now I could know that since it's a number between 0 and 1 that I'm multiplying by, that this is some sort of compressing towards the x-axis, but I don't actually need to know that. I could figure it out. Now, this 3, 0 point is going to stay right where it is. Okay. And now I could think about, okay, well, before when I put 0 in, I got 9. Now when I put 0 in, I'm going to get 9/4 because I do the 0 minus 3, negative 3 squared, 9, but times 1/4 is 9/4. So instead of getting that 9 up there, where, let's see, that was up here maybe, I'm going to be down here at 9/4. So I'll just make a marking for 9/4. And so my whole function has gotten squashed and is a lot wider now. Okay. Now I can do my final transformation. So in this final one here of the 1/4 x minus 3 squared minus 1 just takes the previous one and does a -1, so it drops it down 1. So this point that was at 1, 2, 3, 0 is now at 3, -1. And this point that was at 9/4 before got dropped down by 1. So drop down 9/4, take away 1 is taking away 4/4. So it would now be just at 5/4. Okay, so then I would basically just have this. Okay, so that's the point 0, 5/4. And what I've gotten here is my resulting g of x is 1/4 x minus 3 squared minus 1. And there we have it.